Hello guys, welcome once more to another video in our YouTube channel. So in this video we are going to continue solving the questions of the Pi-Day competition for Terminale. Alright, so like in the previous video I promised that after doing from question 50 to question 55, I'm going to solve from question 45 to question 49. Okay, like I said, don't bother that it is in French. I always try my best to translate. Okay, so 45, given that you have I of n is the integral from 0 to 1 of x to the n times the square root of 1 minus x with respect to x. Calculate I0. 46, calculate In plus 1 in function of In. 47, calculate I1. 48, calculate I2. And 49, deduce In as a function of n. So like we crop the equation and then we solve together. So we are solving from question 45 to question 49. Okay, so I'm just going to drop the equations here. Alright, so let us begin with 45, which is asking us to calculate I0. So 45, we are calculating I0. So I0 is equal to the integral from 0 to 1. We need to replace n with 0. You have x to the power 0 and it is 1. You have just the square root of 1 minus x. So I'm going to write this square root as 1 minus x raised to the power half. Okay, we are integrating with respect to x minus. Now, how do we integrate this? We first of all differentiate the interior of the square root. We get a negative value because when we differentiate this guy here, we have negative 1. Then we multiply it with the power, which is half plus 1. And then the numerator will be 1 minus x to the power half plus 1. Now we need to fit our limits of integration from 0 to 1. So this gives us, so let's just simplify. Now this is going to give us 3 divided by 2. But since it is in a denominator, then we have negative 2 on 3. Okay, at the end we are going to have 1 minus x raised to the power 1 minus x all that raised to the power 3 divided by 2, and it is from 0 to 1. Now when we have negative 2 on 3 into, when we fit 1, we have 1 minus 1 is 0, so the upper limit is 0. So we have 0 minus, we need now to fit the lower limit. Fitting the lower limit as 0, we are going to get 1 raised to the power 3 on 2, which is 1. Okay, so at the end of the day we multiply, we get 2 divided by 3. Let us proceed to question 46. Calculate In plus 1 in terms of In. So we are calculating In plus 1 in function or in terms of In. Alright, so we are going to go via integration by parts to do this. So we are going to begin with letting u to be x to the power n. Okay, what does this mean? It means that our du will give us x to the power n minus 1. We multiply it with n times dx. We could still let u to be the square root, but it is big. I'm letting u to be x to the n, and my dv will be that square root because this question above here I've already integrated that square root, so I'll just copy the result and paste. So my dv becomes the square root of 1 minus x dx. It means that my v is just integrating dv. I'm going to get this guy here but without limits. So negative 2 on 3 times 1 minus x raised to the power 3 divided by 2. But this is the same as negative 2 on 3 times the square root of 1 minus x, all that raised to the power 3. And raising this to the power 3 is the same as raising it to the power 2 and then multiplying it with itself. Okay, now raising it to the power 2 is just giving us the 1 minus x. So we have negative 2 on, so this will give us negative 2 on 3, negative 2 on 3 times 1 minus x times the square root of 1 minus x. Okay, so it means that our I of n is equal to uv. So we have u times v. This is our v. So uv. So let me do it, highlight with this. So uv, so we have x to the n times, we just put a negative 2 on 3 outside here, then we multiply it with all of this. So we have this. Now from 0 to 1, don't forget the limits, minus the integral from 0 to 1 of v du. The integral from 0 to 1 of v du. This is v, right? And this negative 2 on 3 is a constant. It multiplies with this negative here to give us positive 2 on 3. Now du has an n, so we attach the n to the numerator, and then we have x to the n minus 1, x to the power n minus 1. Then we multiply it with everything here. Okay, multiply with that, the x. Okay, so it means that our I of n is equal to, when we feed 1, this will just give us 0, as well as this. When we feed 0, this will give us 0. So it means we just have 2n over 3 times the integral from 0 to 1. Now let us multiply x to the n with each term here. Okay, this one is like a whole term, so I'm just going to call it the square root of 1 minus x. Now this square root is multiplying x to the power n minus 1, because I multiply x to the n with 1, and then I multiply x to the n minus 1 again with x. It gives us minus x to the power n. Just add their powers, the x. Okay, so this will give you 2n on 3 times the integral from 0 to 1. You can now multiply the square root of this times x to the n minus 1. It gives you x to the n minus 1 times that square root, the square root of 1 minus x. Now you follow this negative sign. We need to split the two integrals, minus 2n on 3 times the integral from 0 to 1 still, integral from 0 to 1. We now multiply the square root with x to the n. We just get x to the n times the square root of 1 minus x, the x. Okay, now we identify that this integral here is just I of n minus 1. Okay, because I of n, the power of x here is n, and the square root of 1 minus x is there. So when the power is n minus 1, it is I of n minus 1, and this integral here will give us I of n. So at the end of the day, we can have that I of n is equal to 2n on 3 times I of n minus 1 minus 2n on 3 times I of n. We can multiply all through by 3. We have 3 here. Here you'll be left with 2n. Here you'll be left with negative 2n. We can now add I of n on both sides. Sorry, 2n I of n on both sides. So the left hand side is 3 I of n, 3 I of n plus 2n I of n. On the right hand side, it is 2n I of n minus 1. Okay, so this means that we can factor out I of n from the left hand side, and we have I of n into 3 plus 2n, and we equate it to 2n times I of n minus 1. So it means that what is our I of n equal to? It's equal to 2n divided by 2n plus 3 times I of n minus 1. But the question is asking us to calculate I of n plus 1 in function of I of n. So if I put the power here, if I let n to be n plus 1, it means I need to come here, I replace n with n plus 1. I come here, I replace n with n plus 1. I come here, I replace n with n plus 1. You see, 1 minus 1 is 0. Alright, so the numerator is this. The denominator, you have 2n plus 2 plus that, you have 2n plus 5. 2n plus 5. Okay. Now in the numerator, it's just n plus 1, and then you can factor out these 2. Okay. Now the next part is saying we should calculate I1. Okay. Let us find I1. I1 is equal to letting n to be 0. Okay, we are going to get 2 into 0 plus 1 is 1 divided by 2 times 0 plus 5 is 5, and we multiply it with I0. But I0 is 2 on 3, so at the end we get 2 on 5 times 2 on 3. That's what we have. Okay, next is saying we should calculate I2. I2 is gotten by letting n to be 1. So we have I2 to be 2 times 1 plus 1 is 2. 1 plus 1 is 2 divided by 2 times 1 plus 5 is 7. Then we multiply it with I1. Alright, so we have 2 divided by here you have, in fact, let's just simplify this. This is going to give us 4 divided by 5 times 3. Okay, and this is going to give us 4 divided by 7 times I1, and this is I1, so times I1. So at the end we get 4 squared divided by 7 times 5 times 3. 7 times 5 times 3. Okay, now the last part is asking us to deduce I of n in terms of n. So I'm going to drill you because I want to be very sure that you can do it. Okay, so look at I0. Our I0 is 2 on 3. Okay, look at I1. Let me just write the terms. 2 on 3, comma 2 times 2, or let's say we have here 2 times 2 divided by 5 times 3. Then the next term is 4 squared, which is 2 times 2. Sorry about that. So 2 times 2. So 2 times 2 times 2 times 2 again. Then we divide it by 7 times 5 times 3. Okay, and so on and so forth. So what can we deduce about these terms? We see that this first guy here is for when n is equal to 0. So when n equal to 0, comma, when n equal to 1, and when n equal to 2. So what can we say? We say that when n is 0, the numerator is 2 and the denominator is 3. When n is equal to 1, the numerator is 2 times 2. Okay, and the denominator is 5 times 3. When n is equal to 2, we have 2 times 2 times 2 times 2, and this guy here is 7 times 5 times 3. Look at the denominators. They are now, you have something like the product of odd numbers. Okay, you leave from 3, they go to 5 times 3, they go to 7 times 5 times 3, so you can get the general term. Okay, now see the numerator, you have 2, they go to 2 times 2, they go to 2 times 2 times 2 times 2. You're seeing that when you're at 2, to get to the next one, you need to multiply the first one with itself. To get to this one, you need to multiply the second one with itself, because the second one is 2 times 2. You multiply it with itself. Okay, so this is just a drill to help you to get the general term. When you get the general term, you put your comment in the comment section. I'm going to tell you if it is correct or not. Thank you for watching, and see you in the next video.